In the United States, according to the National Electrical Code, circuit breakers used to protect circuits for ranges, dries, and hot water heaters must be two-pole, double-pole circuit breakers. This means that both conductors of the circuit, the hot and neutral conductors, must be protected by the same circuit breaker. However, there is an exception. Two single-pole circuit breakers can be used if they are interconnected or installed as a common trip circuit breaker. Interconnected circuit breakers are mechanically linked together so that when one breaker trips, the other breaker also trips. Common trip circuit breakers are designed to trip both poles simultaneously if either pole opens. According to the NEC, existing installations that do not comply with the current code are generally allowed to remain in place. However, it is recommended that these installations be upgraded to meet the current code requirements for safety reasons. If there is an older home that has two single-pole circuit breakers protecting a circuit that requires a two-pole circuit breaker, it is advisable to upgrade the circuit breakers to two-pole breakers or replace them with a common trip circuit breaker. This will improve the safety of the electrical system in the home. Electrical safety is paramount, and adhering to the National Electrical Code is crucial for ensuring the safe operation of electrical systems. Understanding the specific requirements for circuit breakers, especially concerning two-pole versus single-pole configurations, is essential for both electricians and homeowners. Firstly, the National Electrical Code mandates that certain high-amperage appliances such as electric ranges, dryers, and water heaters must be protected by two-pole circuit breakers. The rationale behind this requirement lies in the operational characteristics of these appliances, which typically operate at 240 volts, utilizing two hot wires in addition to a neutral wire and a ground wire. A two-pole circuit breaker provides simultaneous overcurrent protection for both hot wires, ensuring that if an overload or short circuit occurs on either wire, both poles of the breaker will trip, effectively disconnecting the appliance from the power source. Secondly, the use of two single-pole circuit breakers to protect a 240-volt circuit is generally prohibited by the National Electrical Code unless specific conditions are met. The primary concern with using two independent single-pole breakers is the potential for only one breaker to trip in the event of a fault, leaving the other hot wire still energized. This situation can create a dangerous condition, as the appliance may still be partially powered and pose a shock hazard. However, the National Electrical Code does permit the use of two single-pole circuit breakers if they are designed to operate as a single unit. This can be achieved through the use of a listed handle tie, which mechanically connects the handles of the two breakers, ensuring that they trip simultaneously. Alternatively, a two-pole circuit breaker consisting of two single-pole breakers with an internal common trip mechanism can be used. These breakers are designed to trip both poles whenever an overcurrent condition is detected on either pole. Thirdly, the requirements for circuit breaker installations can vary depending on the specific edition of the National Electrical Code that is in effect. It is crucial to consult the latest edition of the National Electrical Code and any applicable local amendments to ensure compliance with the current regulations. The National Electrical Code is updated every 3 years, and significant changes can occur between editions. Therefore, it is essential to stay informed about the latest requirements to ensure that electrical installations are safe and code compliant. Fourthly, when replacing or upgrading circuit breakers, it is essential to select breakers that are properly rated for the circuit they are intended to protect. Circuit breakers are rated in terms of their voltage, amperage, and interrupting capacity. The voltage rating of the breaker must be equal to or greater than the voltage of the circuit. The amperage rating of the breaker must be matched to the ampacity of the conductors in the circuit. The interrupting capacity of the breaker must be sufficient to safely interrupt the maximum available fault current at the installation location. Fifthly, the National Electrical Code provides specific guidelines for the installation and wiring of circuit breakers. These guidelines cover topics such as the proper sizing of conductors, the use of appropriate wiring methods, and the grounding and bonding of electrical equipment. Adhering to these guidelines is essential for ensuring the safe and reliable operation of the electrical system. For example, the National Electrical Code requires that all circuit breakers be installed in a panel board or enclosure that is listed for the purpose. The panel board must be properly grounded and bonded to ensure that any fault current is safely conducted back to the source. Sixthly, in addition to the National Electrical Code, other standards and regulations may apply to circuit breaker installations. These may include local building codes, utility company requirements, and product safety standards. It is important to be aware of all applicable requirements and to ensure that electrical installations comply with all relevant regulations. For instance, some local jurisdictions may require that all electrical work be performed by licensed electricians. Utility companies may have specific requirements for the connection of electrical services to their grid. Product safety standards, such as those issued by underwriters' laboratories, establish minimum safety requirements for electrical equipment. Seventhly, when troubleshooting electrical problems, it is essential to follow safe work practices and to use appropriate personal protective equipment. Electrical work can be hazardous, and it is important to take precautions to minimize the risk of electric shock, arc flash, and other injuries. Before working on any electrical circuit, it is essential to de-energize the circuit and to verify that it is de-energized using a voltage tester. Personal protective equipment, such as insulated gloves, safety glasses, and arc flash-rated clothing, should be worn whenever there is a risk of exposure to electrical hazards. Eighthly, the National Electrical Code contains numerous tables and examples that can be helpful in understanding the requirements for circuit breaker installations. For example, Table 310.15. B16 provides ampacity ratings for various types of conductors. These ampacity ratings are used to determine the appropriate size of conductors for a given circuit. Example D3 in Annex D provides an example of how to calculate the size of service entrance conductors for a dwelling unit. These tables and examples can be valuable resources for electricians and other electrical professionals. Ninthly, it is important to note that the National Electrical Code is not a design manual. It provides minimum safety requirements for electrical installations, but it does not provide detailed design guidance. Electrical design is a complex process that requires specialized knowledge and experience. It is recommended that electrical design work be performed by qualified electrical engineers or other design professionals. Tenthly, the National Electrical Code is a living document that is constantly evolving to reflect new technologies, changing safety concerns, and evolving industry practices. It is important to stay informed about the latest changes to the National Electrical Code and to adapt electrical installation practices accordingly. Continuing education courses, industry publications, and professional organizations can be valuable resources for staying up to date on the latest developments in electrical safety and technology. In summary, understanding the National Electrical Code requirements for circuit breakers is essential for ensuring the safe and reliable operation of electrical systems. Adhering to these requirements, selecting properly rated breakers, following safe work practices, and staying informed about the latest changes to the National Electrical Code are all crucial for protecting people and property from electrical hazards. Always consult with a qualified electrician or electrical professional if there are any questions or concerns about electrical installations. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. It's important to understand that the NEC is not law unless it is adopted by a local jurisdiction. However, it is widely used as a benchmark for electrical safety, and compliance with the NEC is often required by insurance companies and other organizations. When it comes to circuit breakers, the NEC has specific requirements for their installation and use, particularly in residential settings. One of the key areas of focus is the use of two-pole circuit breakers versus single-pole circuit breakers for certain types of circuits. As previously mentioned, appliances such as electric ranges, dryers, and water heaters typically operate at 240 volts and require a two-pole circuit breaker for proper protection. This is because these appliances use two hot wires, each carrying 120 volts, to supply the necessary power. A two-pole circuit breaker is designed to trip both hot wires simultaneously in the event of an overcurrent or short circuit, preventing damage to the appliance and reducing the risk of electrical shock or fire. Single-pole circuit breakers, on the other hand, are typically used for 120-volt circuits, such as those powering lighting fixtures, outlets, and small appliances. These breakers only protect a single hot wire, and they are not suitable for use in 240-volt circuits that require simultaneous protection of both hot wires. While it is possible to use two single-pole circuit breakers to protect a 240-volt circuit, this is generally not permitted by the NEC unless the breakers are specifically designed for this purpose. As mentioned earlier, handle ties or common trip mechanisms must be used to ensure that both breakers trip simultaneously in the event of a fault. The NEC also addresses the issue of existing electrical installations that do not comply with current code requirements. In general, the NEC does not require that existing installations be upgraded to meet the latest code requirements unless there is a significant alteration or addition to the electrical system. However, it is always recommended to upgrade non-compliant installations whenever possible to improve safety and reduce the risk of electrical hazards. If an older home has two single-pole circuit breakers protecting a 240-volt circuit that should be protected by a two-pole breaker, it is advisable to replace the single-pole breakers with the two-pole breaker or a pair of single-pole breakers with a handle tie or common trip mechanism. This will bring the installation into compliance with current code requirements and provide a higher level of safety. In addition to the specific requirements for two-pole versus single-pole circuit breakers, the NEC also covers a wide range of other topics related to circuit breaker installation and use. These include the proper sizing of circuit breakers for different types of circuits, the use of appropriate wiring methods, the grounding and bonding of electrical equipment, and the installation of overcurrent protection devices. It is important for anyone working with electrical systems to have a thorough understanding of the NEC requirements for circuit breakers and other electrical components. This will help to ensure that electrical installations are safe, reliable, and compliant with all applicable codes and standards. If there are any questions or concerns about electrical installations, it is always best to consult with a qualified electrician or electrical inspector. These professionals have the knowledge and experience to ensure that electrical work is performed safely and in accordance with all applicable regulations. Furthermore, it is crucial to remember that the NEC is a minimum safety standard and that exceeding these standards is always a good practice. For example, using higher rated circuit breakers than required by the NEC can provide an extra margin of safety and reduce the risk of nuisance tripping. Similarly, using higher quality wiring and electrical components can improve the reliability and longevity of the electrical system. By taking a proactive approach to electrical safety and going beyond the minimum requirements of the NEC, it is possible to create electrical installations that are not only safe but also efficient, reliable, and long-lasting. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents and injuries. By understanding the NEC requirements for circuit breakers and other electrical components, and by following safe work practices, we can all help to make our homes and workplaces safer for ourselves and others. Remember, when working with electricity, safety should always be the top priority. Take the time to educate oneself about electrical hazards, follow safe work practices, and consult with qualified professionals when needed. By doing so, it is possible to minimize the risk of electrical accidents and injuries and create a safer environment for everyone. In the context of older homes, the continued use of two single-pole breakers for circuits requiring a two-pole breaker presents a nuanced situation. While the NEC generally allows existing installations to remain as they are, provided they were compliant with the code at the time of installation, there's a strong recommendation to upgrade for enhanced safety. The primary concern lies in the potential for unequal loading and the risk of only one breaker tripping during a fault, leaving one leg of the circuit energized. This can create a hazardous condition, especially with appliances like electric ranges or dryers, where users might assume the appliance is completely de-energized after a breaker trips. Upgrading to a two-pole breaker or single-pole breakers with a listed handle tie mitigates this risk by ensuring both legs of the circuit are simultaneously disconnected during an overcurrent or short circuit. This upgrade is particularly advisable when the existing breakers are old or show signs of wear, as their reliability may be compromised. Furthermore, any renovation or significant alteration to the electrical system should trigger an upgrade to meet current NEC standards, including the use of two-pole breakers for appropriate circuits. The decision to upgrade should also consider the overall condition of the electrical system, including wiring, grounding, and panel capacity. A comprehensive electrical inspection can identify potential hazards and recommend necessary upgrades to ensure the safety and reliability of the electrical system. The cost of upgrading to two-pole breakers is relatively low compared to the potential consequences of an electrical fire or shock. It's a worthwhile investment in safety, especially for older homes where the electrical system may not have been designed to handle the demands of modern appliances and electronics.